Assalamu alaikum. Today on 24 December 2020, I am starting lecture number 1 for week number 12, and the topic of my lecture is Introduction of Synchronous Generators. First of all, I would like to revise the concept that what is the difference between a synchronous machine or an or an induction machine. Both are AC machines. Primarily, there are two types of AC machines. One is the synchronous machine, and the second is the induction machine. What is the principal difference between a synchronous machine or an induction machine? In synchronous machines, field current is provided by a separate DC power source, while in induction machines, this field current is provided by means of magnetic induction, or what we can say transformer action. But since there was a 2 weeks gap, so I should revise the concept that what are the field windings and what are the armature windings. So first of all, in an electrical machine, there are two major parts. One is the stationary part known as the stator, and other is the rotatory part known as the rotor. Similarly, in an electrical machine, generally there are two windings. One winding that is being located at the stator and known as the stator winding, and the other winding that is being located at the rotor, which is known as the rotor winding. But we use the word armature winding and field winding instead of stator winding and rotor winding. So what is this concept? If there are two windings, then which winding is the armature winding and which winding is the rotor winding? To answer this question, we realize the fact that the field of which winding is dominant. For example, in AC machines, the field of rotor becomes dominant. So this dominance awards the word field winding to the rotor's winding. So in AC machines, field windings are the windings that are located at the rotor of the machine. While since the main voltage is induced on the stator winding, so we say that stator winding is the armature winding. Now the part which contains the stator armature winding is known as armature. So in AC machines, we say that stator is the armature. Okay, so this is the principal difference between induction motor and the synchronous motor, or induction machines or synchronous machines, that in synchronous machines, field a separate DC source is provided to a separate DC source is basically given to provide field current. Okay, while in induction machine, again field winding is on the rotor's winding on the rotor, but this time we don't use a separate DC power source for the provision of DC field current. Rather, we provide field current using a magnetic induction or transformer action. Okay, so chapter number 5 basically covers synchronous generators. Synchronous generators are also known as alternators. Why alternators? Because they generate AC. So alternators are AC generators. Okay. So we often use the word alternators instead of synchronous generators. Okay. So this is basically a short introduction of synchronous machines. Why we use the word synchronous? Because synchronous machines rotate at a fixed speed. They do not change their speed. They rotate at a fixed constant speed. Therefore, we use the word that these machines are synchronous machines. Now coming to the starting principle of synchronous generators. Whenever I shall start a chapter regarding any specific motor or generator, I would I should always tell you that how this machine will start. What is the starting principle of this machine? And you should very carefully listen to the starting principle, because these starting principles are different from each other. For example, when we talk about the synchronous generator, so its starting principle is that we provide a DC field current to the rotor's winding, and we provide so when we provide a DC field current to the rotor's winding, what happens that there establishes a fixed magnetic field. Now, since the machine is generator, so we will rotate the rotor of the machine by means of a prime mover. And why we are doing so? Because it is a generator, so it needs mechanical energy to be given as an input so that it can convert the mechanical energy into electrical energy. So since synchronous generator is also a generator, so what happens that first of all we provide uh, its field winding with a fixed DC source. So this fixed DC source establishes a magnetic field at the rotor's winding. Now this rotor is being rotated by a prime mover. Anything that would rotate the rotor of the generator would be named as prime mover. For example, if water is falling at the turbine and the turbine is coupled with the shaft of the generator, and due to the fall of water, now if the turbine is rotating and uh, turbine was coupled with the generator's shaft, so the generator is rotating due to the rotation of turbine, so we will say that this turbine is prime mover. In your lab, whenever we will perform an experiment related to the generator, what we will do that we will rotate the generator with the help of another motor. Now if a motor is rotating the generator, then this motor is a prime mover. Prime mover is basically an instrument that rotates the generator at its first place to provide the generator with the mechanical energy. Okay, so in our hydroelectric dams, what happens that water falls at the turbine, and the turbine is basically coupled with the shaft of the generator. So when the turbine moves or rotates, the generator shaft rotates, and hence what happens that the fixed magnetic field that was established due to a separate DC source becomes a rotational magnetic field. And we know that whenever there is a rotational magnetic field, it will induce three-phase set of voltages that are equal in magnitude and differed by 120-degree phase angle. So what happens that when the shaft of the synchronous generator that was provided with a fixed magnetic field is rotated by the prime mover, this fixed magnetic field becomes rotational magnetic field. And now this rotational magnetic field induces three-phase set of voltages in the stationary winding of stator. And these three terminals now offer three-phase voltages, that is electricity. What is production of electricity? It is basically generation of electric voltages. So due to this rotational magnetic field, due to the relative motion between this rotational magnetic field and the stationary winding of the stator, three-phase set of voltages are induced at the three terminals of a three-phase synchronous generator, and hence we say that the generator has established the voltages. Now, if these three phase terminals are connected to a three-phase load, they can provide three-phase currents. Okay. So this is the phenomena. This is the starting of a synchronous generator. To start a synchronous generator, first of all, we will provide its rotor winding, its field winding with a separate DC source. Due to this separate DC source, what happens that a fixed magnetic field is established at the rotor's winding. Now this rotor is being rotated by a prime mover, so its fixed magnetic field becomes the rotational magnetic field. And in chapter 4 we have studied that a rotational magnetic field can establish three-phase set of voltages in a three-phase winding. So what happens that this rotational magnetic field has a relative motion with the stationary stator winding. So this rotational magnetic field establishes three-phase set of voltages at the three terminals of the stator. And we say that now these three-phase set of voltages are basically electricity. So since the three-phase set of voltages that are dominant output of this generator are established at the stator winding, we say that the stator is the armature of the machine. Okay, so this was a short introduction of synchronous machines and synchronous generators and the starting principle of synchronous generator. So if you have any question, you can ask.